Okay, and here we are to look at the answers for worksheet 2A, dealing with piecewise functions. All right. Now, number one, looking at this function, this is a little more the domain range, x, y intercept, that sort of thing. The domain is going to go from -6 to +6. And it does have endpoints on either end. The range will go from -4 up to +5. X-intercepts are right there, which looks to be about -4.2. And, so long as it's something reasonably close to that, I realize we're approximating here. And the same thing is going on there. That might be, I don't really need the union there. But also something like about 5.3 maybe. The y-intercept is definitely where y is 0, y is 3. Okay. Now, we've talked before about things like absolute max and relative max. When they just ask for the maximum or the minimum, they just want to know what is the highest and the lowest values for x. That's all they want. The highest values, for y. Highest value for y here is 6. That is the maximum there. And the lowest value is -3. Now, I want to point out something here that the max and the mins tend to relate very much to the range. Now, why is that go to 5? Oh, because this is a different graph. Okay. I was thinking it was the same graph. It's just been adjusted, that's all. All right, so minimum is -3, maximum is 6. We're good there. All right, this guy, we need to do increasing and decreasing according to interval notation. Now, you have seen me before go through and just kind of mark with the x values of the places where it changes. It changes here at -1, changes there where x is 3, and it changes here where x is 6. So now we've got only one place that it's increasing from -1 to 3. But it's decreasing from -4 to -1, but also from 3 to 6. Oh, and I guess we can do that. And we can do that. Because those are not places where it's neither going up or down. It's actually all part of the going down at this point. All right, time for some word problems. Right, the function that models this situation. All right, so we're just after the function and that's it. We're just trying to function. All right, part 1 talks about charges you $10 a shirt for the first 75 shirts. So I guess, now understand something here. If we do this, and the first 75 would be less than or equal to. But here's the problem. So if somebody walks in with an order of 75 shirts, it's $10 for the whole thing, all of it? No, it's $10 per shirt. So if X represents the number of shirts, then we're going to do that. $10 per shirt up to the first 75. Now, after the first 75, when you go up to 150, that $7.50 per shirt. All right, so they're now only charging $7.50 per shirt for when X is greater than 75 up to 150. Now the question is, does 150 count for the $7.50 price or the $5 price? And look at the last sentences. After you purchase 150, then the price will decrease to $5. So 150 is included in the 750 price. And then ultimately they're saying it's $5 a shirt for when X is greater than 150. I guess you really have to say here that you can't have 0 shirts. So I guess I will do it this way. You have to do that. Because you can't have negative shirts. That's just not going to happen in the real world. Okay? Now, what function of A would make this a continuous function? Well, remember the question becomes right here where the baton is handed off, -2. If I plug in the -2 in the first guy, that's 3 times 4 plus 4, which is 14. So now I'm going to take 5x plus a. Well, I already know that 5x is 5 times -2. And I know that it has to equal 14 because these guys have to match. Well, from here on out, it becomes algebra. -10 plus a. If I add 10 to both sides, I get a equals 24. And that's what would make it match, make it the function continuous. All right, Prunella lives in Brooklyn. Goes out each day in the morning. Graphs represent her displacement around the city through different days. Now notice that this is saying distance from the house, and this is saying time. So she goes away from the house, then she stays the same distance away from the house, and then she comes back to the house. All right, so what kind of units of measure are we using here? What would make sense here? Well, if you're going to write the story, you got to figure out, if she is going away from the house, how long are we talking about? Are we talking about hours here? Are we talking about days, minutes? You know, did she leave the house for 2 minutes, stay somewhere for 5 minutes, and then slowly head back home again? You're not going to get very far from the house in 2 minutes. Maybe hours would be the best unit of measure of time, although you could make the argument for days. All right, so the domain, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The domain is going to go from 0 to 13, and the range, now, I don't know if you see that or not. That's 2. So that means each notch here is worth 2. 2, 4, 6, 8. Whoops. I got those backwards up there, didn't I? Oh, no, I did get it right. It goes from 0 to 13, and the range goes from 0 to 8. I guess technically I should be putting brackets on these because they are fixed in their endpoints. And the story. What would take her 2 hours to get there? And then would take her 1, 2, 3, 4, 5, 6 hours to get home. Maybe she rode a bus to the library. And walked home. That would explain the 5-hour stay in the middle. Rode the bus, took her 2 hours to get there. She stayed late, the buses weren't running anymore, it took her 6 hours to walk home. It's a long day. Must have been a graduate student or something. Anyway, what you wrote for your story, so long as it makes sense on those lines. That's the most important thing. All right, now here we have the same idea but a different graph. Here the units are still 2 going this way. All right, she is still, the description is still the same. So she went somewhere slowly for the first 1, 2, 3, 4 units, and then stayed 1, 2, 3, 4 units, and then 1, 2, 3, 4, 5, 6. So the domain is going to be from 0 to 14. And this goes up this far, 1, 2, 3, 4, 5, and they're worth 2 apiece. So the range goes from 0 to 10. So, maybe she was riding a bike to a friend's house. We could still count this in hours. You could come up with a story that would be minutes. If this were, she was walking to the corner convenience store to where she walked out of the house and walked up and kind of had to stand at the corner for the red light, and then she continued walking to the drugstore. It also could be, did she rode a bike somewhere, stopped and had lunch, and rode her bike some more. And maybe she was going to go spend the night with a friend or something like that. All right, same issue with number 6. And I'm just for the sake of consistency, I'm going to be doing hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hours. Going that way. And the range goes up 2, 4, 6, 8, 10, 12. Oh yeah, I need to do that. I forgot to do that on the last page, didn't I? We'll scroll back up and fix that. We'll see who is actually watching the video and who is just going to the screen and copying the answers without listening to what I'm saying. All right, so what would a story look like that would be here? Maybe she was walking somewhere and, she walked for a few hours and then she thumbed a ride, hitchhiked a ride with somebody, or maybe she walked to the bus stop and then caught the bus, and then she got where she was supposed to go and she stayed there for several hours. So I kind of like the idea of walking to the bus stop, rode the bus for 2 hours or for 1 hour, and then stayed somewhere, maybe the mall. shopping at the mall or something like that. Okay. All right, now let's take a straight up piecewise function and graph it. Now, the first part here, let me see something here. I got several of these. I think I'm going to pause it here after number 6 and we'll pick up with number 7 in a different video.